Progress.
This lesson introduces section 6.2, which covers some specific quadratic functions involving the vertex. So we did a quick review in class of the general form of the quadratic function, which is, get in here. So this is ax squared plus bx plus c, where the ax squared is your quadratic term, bx is your linear term, and c is your constant term. So I'm going to go ahead and give you the vertex form, and then we're going to sort of break it apart and see how each piece works and then how it all fits together. Well, actually, we won't get to the all fit together until tomorrow because class got cut a little short. But go ahead and have this with you. The vertex form is, so let me just write this in function form, f of x equals the standard form. So vertex form is f of x equals a times x minus h squared plus k. And this may look familiar to some of you if you remember when we were working with the absolute value of linear. So the linear form of this, we use the h and the k with absolute value. So this is somewhat similar, but with the quadratic form. So we've got a squared term. And going back as well, in the last video for the lesson on section 6.1, the vertex, your x coordinate is your h, and your y coordinate of the vertex is your k. So that's where the h and k come from that go into this function, which means that from the function, you can already glean the information of what your vertex is. All right, so let's get into what that looks like. So example one is on the bottom half of page 241. They've asked us to graph two different functions, and this takes the...
Recording in progress.
So we have the function g of x equals x minus 2 squared, and then h of x equals x plus 3 squared. All right, so when we talk about these two, we always want to compare them to the parent function, f of x equals x squared. So in the graph, they've got it in your book, and I've got it kind of as best I can right here in front of you. That purple dotted-ish line, that's your parent function. So anytime you have no coefficient of x squared, it's just an understood 1. It starts at the origin, it moves up 1, so it's a bit exponential. It moves up to 1, and then it's 4, and then it's 9, and it just keeps going. So it hits symmetrically, hits x values, y values that are perfect squares. So now I want to talk about the math of how we would function these how we would graph these. So let's go ahead and if we look at x minus 2 squared, I'm going to go ahead and start like they did. I'm going to start with 0. Let's see, I'll keep the color here. So if I start with x equals 0, then I have 0 minus 2 squared, which is negative 2 squared. And so that gives me a y value of 4. X equals 1. Then we have 1 minus 2 squared, so that gives me a negative 1 squared, which is 1. If I pick 2, 2 minus 2, which is 0, and 0 squared is 0. So again, let's look at these ordered pairs, 0 and 4, 1 and 1, 2 and 0. 3 gives me 3 minus 2 squared, which is just 1 squared, so that's 1. So you can see I've just found some symmetry here, and this is lower, so that's probably my vertex. And then, so I'm going to go up to 4, and I end up with 4 minus 2 squared equals 2 squared, so that's 4, and there's my other point of symmetry. I've got 4 and 4 on my y-axis. And when you look at the graph here, again, these guys are falling at y equals 1. This next one here, these are at point, let's see here, maybe it adds up. If I change that, yeah. So if I change that to my background, you can actually see your points. So that's 1, and then 2, 3, 4. And then my next one is 5, 6, 7, 8, 9. And then they're symmetrical back and forth across the axis of symmetry. All right, and so we can graph this. This gives us our vertex. Okay. All right, so let's go ahead and do the other one. So with the function h of x equals x plus 3 squared, I'm going to use what they gave me just to start off with. So I'm going to start at -1. Keep my colors the same here. -1, because this one is all on the, you can tell from the graph it's on the left side, but I'll show you how to figure that out. We'll go over that in a second. So if it's -1, then this is -1 plus 3 squared, so that's 2 squared, so it's 4. -1, 4. -2, we have -2 plus 3 squared, that is 1 squared, so that's 1. And then at -3, we have -3 plus 3 squared, that's 0 squared, so that gives me 0. -3, 0. -4, start to go back up. It's -4 plus 3 squared, which is -1 squared, so that's still positive. Negative times negative, positive. So -4, and then here's our points of symmetry, which means that's going to be our vertex. -5 is -5 plus 3 squared, so -2 squared, but still gives us a positive 4. Again, creates another pair of like symmetrical points up the y-axis. And then when you look at the graph, you can see that. So this is the math of why the function works and why it gives you why you can just look at these functions and know what your x and y coordinates of the vertex is going to be. So when you can figure that out, that actually tells you if you have to draw a table, you don't have a graph to look at to figure out what the vertex is, you can calculate it, and that tells you where to start to make your table. So I would always start at the vertex and then move left and right on my x values from that to get my other points to draw the parabola. All right, so the quadratic function in vertex form, I just want to write that again. So that is your f of x equals, let's see, a times x minus h squared plus k. All right, so let's look at one thing we talked about in class is why, when I subtract 2 from x, do I actually move up the x-axis, +2 for my vertex, and why, when I add 3 to x, do I move down or left on my x-axis? So let's talk about that. That's because the function includes a subtraction. It includes a negative. So if we are looking at a vertex form of the quadratic function, and we want to calculate the h and k so we can figure out what our vertex is. So we have an x here. We have our subtraction. So that means that h is actually a +2, because we would not include the negative in the value of the term that follows it because it's already part of the formula, the just basic vertex form of this function. And then k, so what is our k in g of s? So I just recreated what we just did in our example. What's k here? There's nothing there. So you've got this understood +0. So that means that the y coordinate at the vertex is 0. Therefore, your vertex falls at coordinate or ordered pair 2 and 0. So when you look at that in your graph, you can see that that's the case. And if I change this to you'll see that there's, that's my second point. And that's where it falls. That's why when it's negative, it actually moves right, because your x coordinate is just the number. It's a positive 2. So that's why we move right. Now with k is nice and easy. Finding that y coordinate, that means if it's up, then it's a positive y. If it's down, it's a negative y. You know, because the plus is already included in the formula. So that one is a little more intuitive. So let's look at the example here though. How, if our formula here is x minus h squared, then how do I get from a subtraction to an addition? So what we have to do is we have to write this like it has to include a subtraction symbol, but it must mean plus. So that means that our h is actually a negative. And I probably should have used a staple bracket. But anyway, so x plus 3 means the same thing as x minus negative 3. So that way we keep the subtraction from the formula in place, but we can create an expression that means the same thing as x plus 3. So that is why our h value is in fact negative 3. And then k, of course, there's nothing there, so we have an understood 0. So we have 0. So our vertex falls at negative 3, 0. And when we go back up to our graph, we see that, and if I have the thing here, that's 1, 2, 3. It falls at negative 3x, 0y. So that's why when it's x plus 3, you actually move left, move down the number line, the x-axis. When it's x minus 2, your x coordinate of the vertex is actually a positive number, and you move up to the right of your x-axis. Okay, all right, so just wanted to make sure I went over that for the ones that were not in class. Let's go ahead and look at some examples. So we just learned, our first example covered just the basic x minus h squared. Now I want to add an actual value for k and show you what that looks like. I have left the graph here because I'm not going to put y'all through trying to watch me draw all of that again, but I do want us to do the math together. So for this, we're going to pick, so I know based on my form here that well, I do know, but so this is my h, right? And this is my k. So I can go ahead and calculate my vertex that's negative, which is part of the formula. So that means I'm thinking here, my x coordinate at the vertex is a positive 2, but that's a subtraction of 3 instead. So the formula has an addition. So that means that this is negative 3. So what that means is when I go to actually do the table for this, I'm going to start at my vertex, and then I'm going to go up 2 and down 2. So if x is 2, then I know it's going to end up being negative 3, but let's just do math. So this is 2 minus 2 squared minus 3. Well, 2 minus 2 is 0, and 0 squared is 0. So my this y is negative 3, which is where I know my vertex is going to be based on the formula. So now I'm going to go up 1, so that would be 3. All right, so this is 3 minus 2 squared minus 3. 3 minus 2 is 1. 1 squared is 1. So this is 1 minus 3. So that is negative 2. Yep. So at 3, negative 2. And then I'm going to go down 1. So that's a 1. So that's 1 minus 2 squared. I know this is probably going to bother you that I'm like all out of order with my x's. But I start at the vertex and I move up 1, down 1, up 1, down 1 until I have my 5 points, and then I can draw my parabola. Okay, so minus 3. So 1 minus 2 is negative 1. Squared is still 1. 1 minus 3 is negative 2. So you can see how there's my next symmetrical point from my vertex. And so now I went up to 3, so now I'm going to go up to 4. So 4 minus 2 squared minus 3, that's 2 squared. So 4 minus 3 is 1. So 4 and 1. And then I'm going to go down to 0. So I have 0 minus 2 squared minus 3. Oh, that's messy. So negative 2 times negative 2 is still 4. 4 minus 3 is still 1. And so I have 0 and, 1. Okay. Now, if you look at my graph, the pink is what I just created. I guess let's go ahead and look at this with the points. There we go. Okay. So vertex does indeed fall at a positive 2, but negative 3. And then you can see as I go left from my vertex, I go up 1, left 1, and then on the right also I go up 1, left 1. And then from there I go, so that's my 3, negative 2, and 1, negative 2. And then at the y-intercept, we have 0, positive 1, and then perfectly symmetrical across my axis is 4, positive 1. And so that creates my parabola. And that makes sense because it's positive and it's just your standard x squared. So, and then the purple dotted one there that I have is my x squared, or yeah, my parent function here. All right, so one other thing important to notice about the vertical, the axis of symmetry. So the axis of symmetry falls at the vertex, so x equals h. So you know that as well. So x, your axis of symmetry is always going to be x equals h, which in this case, because h equals 2, that means that our axis of symmetry falls at x equals 2. Okay. Let me go ahead, make sure I'm not missing anything. We talked about the vertex form. Okay, so this one adds the a. So again, back to the formula. This is a times x minus h squared plus 1. And we want to add the a. I believe this is where I left off in class.
Recording in progress.
Yeah, this is where I left off, so I'm going to do that as well in the video. We'll review this last bit in class tomorrow, and then work through some of the homework as well before I give y'all some to do tomorrow night. But if you have any questions, as always, email me or jot them down and ask them to me in class tomorrow. All right, thanks so much, guys.